Now we have to attempt a few problems on Coulomb's inverse square law. So what is the formula? Force F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now we have an equilateral triangle of side A and we keep three similar charges at the three vertices of an equilateral triangle of side A. Then find out the force on any one charge due to the remaining two. What we have to find? The force of electrostatic force on any one charge due to the remaining two charges. Okay. For example, if we can take this charge is 1 and this charge is 2 and this charge is 3. Now, what is the question? Find out the force on 3. Find out the force on charge 3 due to the remaining 2. Due to the remaining two charges. So now we can take force on 3 due to 1. It is in this direction. Okay. It is force on 3 due to 1. And next force on 3 due to 2 is in this direction. It is force on 3 due to 2. So all these sides are equal since it is an equilateral triangle. Now we have to calculate force on 3 due to 1. It is, we can take this as K. Then K into similar charges Q into Q, Q square by A square. So F31 is how much? KQ square by A square. Now we have to calculate force on 3 due to 2. So it is also equals to how much? KQ square by A square. Because all the three charges are similar and it is a equilateral triangle. Now it is equation number 2. Okay. So it is the one force and this is the another force. Since it is an equilateral triangle, the angle is 60 degrees. So that's why the resultant force is in this direction. Since these two are having equal magnitude, we can write it as for simple calculation, we can take this is F as well as this is also F. Then the resultant force or net force can be written as root over F square plus 2F square cos 60. Then how much? We obtained F square plus F square 2F square into, we know that what is the value of cos 60 degrees? 1 by 2. 2 gets cancelled. What is remains here? F square plus F square plus F square means it is a root over 3F square. Means it is root 3 into F. We know that root 3 into F. What is the value of F? KQ square by A square. So this is the net force on any one charge due to the remaining two. Similarly, we have to calculate the net force on any one charge of square. For example, it is one square of side A. Now we keep similar charges at each vertex. Now it should be 1, 2, 3, 4. Okay. Find net force on charge 4 due to remaining 3 charges. So the force on 4 due to 3 is in this direction. Since these two are similar charges, repulsion is there. So it is the direction of force on 4 due to 3. And in this direction, the force in this direction, force on 4 due to 1x and force on 4 due to 2x. Okay. Now we have to calculate these three forces and we can add these three vectorially. Okay. To obtain the net force or resultant force. Now, what is the magnitude of force acting on 4 due to 1? It is K into Q square by A square. And the next force acting on 4 due to 3. It is also KQ square by A square. So we know that these two forces are acting perpendicular to each other. Okay. So the resultant can bisect these two forces. That's why it should be taken as F dash, where F dash is the net force or it is a resultant due to force on 4 due to 1 and force on 4 due to 3. It should be taken as F dash. So what is that F dash? For example, it is F and it is F. So we can write it as F square plus F square. So it is simply root 2 F. Okay. Now here it is A, here it is A. Then we obtain this side as root 2A. Now what is the force on 4 due to 2? It can be taken as F 4 2 is equals to K into Q square by R square means root 2A whole square. That means it is KQ square by 2A square. Here the resultant of these two is root 2 into KQ square by A square. Now since these two are along the same direction, we can add these two forces directly. So the net force on 4 is F dash plus force on 4 due to 2. What is F dash? Root 2 into KQ square by A square plus here KQ square by 2A square. And if we can take common KQ square by A square, then what is remains here? Root 2 plus 1 by 2. So that is the answer.